This is the laptop that we use for collecting data in a demonstration rather than a hands-on experiment, because the whole class could see what's on the screen. The software on this laptop is Logger Pro, made by Vernier Software and Technology. I'm going to click on this icon once to run Logger Pro. There is a temperature probe here, which is connected with the USB plug to the computer right there. It's just a USB connection. And when the light is green, that means the thermometer is talking to the computer. When the light is red, that means the thermometer is not talking to the computer. Usually the light is red until you open this program, Logger Pro, and the light turns green once the program is open. You could see that the program already knows that it has a temperature probe connected. I have preheated the water by a lot, so it won't take that much time to see the water boil. It's important to know that this laptop needs to be plugged in all the time because the battery is very old. We use this VGA cable plugged in we plug it in right there when we want to project to a projector or a smart board. When you do that, the other end of the VGA cable plugs into the smart board or the projector. When you want to project, sometimes it's necessary to press the FN key and then press this button, F5, to tell the computer that you want to project the screen to another device also. Sometimes it's necessary to press those buttons more than once, the FN and the F5. Now, before we start to collect the data, you got to set up the data collection so that it gives you enough time to collect the data. For this experiment, I recommend at least 30 minutes, and you have to measure the temperature, or you have to let the machines, let the devices here measure the temperature twice every second. That's 120 samples per minute, just like that. When you're ready to collect the data, you press the green collect button, and the data is coming in. You can see the temperature data and the time data right here. Now, it's not boiling yet, but it will boil shortly. The data is automatically graphed here, but it's hard to see unless you press the A buttons. You have to press the A or auto scale button, and that will cause the computer to zoom in on the graph automatically all the time so you could see the data. And the temperature is rising. It looks like a staircase here, not because the temperature is rising in steps, but just because we don't have a lot of data in this graph, and the software is drawing a line to each data point. Now, as we collect more data, the line will smooth out, and it will stop looking like steps. This is also why it's important to collect at least two temperature. It's important to measure the temperature 120 times every minute, meaning twice every second, so that you can have enough data to get an accurate graph that isn't so stepwise. You can see some boiling has started there, and it's only 99.4 degrees Celsius. All right. The temperature is still rising, so not all the water is boiling there. You could see that temperature is starting to level off as more and more of the water boils. Please notice that the thermometer probe, the temperature probe, is in as far as I could get it deep into the water while not touching the glass. It's important that the thermometer does not touch the glass so that it's always measuring the water and not the glass. It's also important that I've got the heat to the maximum here, and I haven't touched the heat knob this whole time. If you touch the heat knob, then students might think that this graph was going up and then leveled off because you touched the heat knob. But it's important for them to understand that this leveling off happens because the water is boiling, and all the heat energy is going into changing the water from liquid state to gas state. That's where the energy is going. The energy is not going into raising the temperature. Before the water boiled, the energy, the heat energy from the hot plate was going into raising the temperature. So there's a big difference between what was happening here and what's happening here. the boiling point of water is really 100 degrees Celsius. So why is this boiling when it's not 100 degrees Celsius? There are two reasons. The first one is that the thermometer might not be accurate, because this is for educational purposes. Sometimes these things are not very accurate, but the second reason is that we might have low pressure today. If there is a day when the air pressure outside is lower than usual, then the temperature at which water boils will also be lower. In fact, if you were to do this experiment on a mountain, like in Colorado or maybe even Big Bear Mountain, where the air pressure is lower outside, then water will boil at an even lower temperature than this. Well, I think you get the idea here that the temperature stops changing when the water is boiling. So the boiling point of this water, according to this thermometer, seems to be 99.8 degrees Celsius. I'm just looking at this number here that's not changing. That's how I figured that out. And there are other ways to do that. I'm going to stop the data collection now. Stop. And I'm going to turn off the heat and the stirring. The stirring is necessary because we don't want the water to boil with big bubbles. The stirring mixes the water up so that the water boils with small bubbles. You can also do this by putting a rock in there, or a little wooden stick, boiling chip or a boiling stick. That will make the bubbles small. And it's important that the bubbles be small, because if the bubbles are large and water pops out, that could hurt somebody like you. But it's also very fun to watch the stirring happen automatically. Is it still stirring? No, it's not stirring anymore. It stopped stirring. Okay, so I'll just cool off by itself. Now I have stopped collecting the data because I wanted to show how to take an average on this graph. Now, this is not necessary. I mean, students get the idea just by looking at the flat part of this graph, but it's sometimes, for some students, it's interesting to take an average. So I make sure that this is auto-scaled, so this is the best possible view. And now I'm going to take an average here. So this is a flat part of the graph right here. I'm going to click and drag this flat part of the graph, and I'm going to take an average. So there's a stat button here. This button, it says stat, or statistics, and when I click on that, I get some statistics here. What I'm looking for is the mean. The mean is 99.8 or 99.81. So the boiling point of this water, according to this instrument, this thermometer, and the software, is 99.8 degrees Celsius, or 99.81 degrees Celsius. And that's it. Thank you very much.